All right, welcome to this session about continuous performance testing with JfrUnit. And it's a short slot, but I would like to cover 3 objectives during that talk. And the first one would be, I would like to talk about continuous performance regression tests using 2 tools called JDK Flight Recorder and JfrUnit. Secondly, I would like to talk about how we can analyze performance issues using another tool called JDK Mission Control, or JMC for short. And lastly, I would like to speak how we can inject flight recorder events into third-party libraries using JMC agent. So it's quite a bit. Let's get started. A few words about myself. I work as a software engineer at Red Hat, and there I lead the Debezium project. Debezium, it's an open source platform for change data capture. And fun fact, as this conference is brought to you by the friendly guys of Scylla, the ScyllaDB change data capture connector, it's based on the Debezium CDC framework. So that's a nice coincidence. There's a few other things I work on, and one of the projects is JfrUnit. So that's a tool I work on in my spare time, and that's what I would like to present to you today. So let's see what we can do with it. And to set the context, let's think a little bit about regression tests from a functional perspective. So in this area, I would say the problems are pretty well understood. So you have tools like unit tests, integration tests, and it's a well understood domain. People implement those tests. And now if something fails, something breaks, they change their code, something doesn't behave as it used to behave, you will find out about it using those tests. So that's pretty well understood. You have those tests running in your IDE or running on a CI server. So pretty much everybody's doing that. But things are looking a bit different if we think about non-functional aspects of our software, and in particular, performance regression tests. So their automation is much less common. And I would say the reason for that is that, well, if you do performance tests on metrics like throughput or latency, well, those tests, they are very much dependent on the specifics of the execution environment, so the size and the capabilities of your hardware, which means you need to have very production-like hardware to run a performance test should it provide you with the same realistic results. And, well, if you take your test and then you run it on a developer laptop, for instance, results wouldn't be very representative. So you have that dependency on the environment. And also related to that, of course, there's load on the environment. So let's say you would like to run some sort of performance tests on your CI server. So maybe there's other concurrent jobs going on. Well, they would eat lots of CPU cycles, again, impacting the results of your performance test. And all those things make it very hard to implement meaningful, stable tests based on those actual performance metrics like latency or throughput. And this is where JfrUnit comes into the picture. And it tries to provide a fresh angle, a fresh perspective to this topic. And the idea is, instead of measuring and asserting those actual performance metrics, here we are thinking about asserting proxy metrics. So for instance, the object allocation rate our application is doing, or the I/O which it is doing with the database. And the idea there is, if you have a regression in those proxy metrics, that's a strong indicator that also there might be a performance regression in your application. So let's say suddenly your application is doing 10 times as much database I/O for a particular use case as it used to do before. That's a pretty strong reason to look into this and understand what's going on. So that's the idea of JfrUnit, to assert and measure those proxy metrics. And this is based on this tool JDK Flight Recorder. Flight Recorder, it's coming with JDK, and it gives you performance insights via all kinds of events. And we will touch on that later on. So JfrUnit is using Flight Recorder events. You execute those tests as your unit tests, which means you get very quickly feedback. You can run those tests in your IDE, and you will get feedback very early on. And also, there's this tool, JDK Mission Control, JMC for short, which then can use to analyze your flight recorder recordings and see what's going on. So we will see how all that works together. So let's see how such a JfrUnit test looks like in a nutshell. And there's different ways you can go about implementing them. There's a Java API. In this case here, I'm using this Spock-based flavor. And there you implement this sort of specification. And a few things are happening. So the first thing is you specify which of the flight recorder event types you would like to enable. So in this case, I'm enabling the events for the garbage collection and thread sleep calls. So this is what I'm doing to set up my recording. And then within the test itself, I think it's pretty self-descriptive. So I have this when part, and there the actual code under test is happening. So this is the functionality or my business functionality, I should say, which I would like to analyze. So this will trigger some flight recorder events. And then in the then part, I analyze them. And now this test, for instance, would fail if there wasn't this garbage collection event, or if there wasn't this thread sleep event with the right duration. And of course, you could think about taking this to another level and assert all kinds of events, as we will see in a bit. But the big advantage of this is now those tests will be very stable. So let's say, again, coming back to database I/O, it doesn't matter whether this test runs on our laptop or in our CI environment, or whether there is concurrent load, this will always be the same. So we have a stable and reliable means of implementing performance regression tests. So let's talk about two more tools which we need to use in this context in a little bit more depth. The first one, Flight Recorder. I mentioned it already. In a nutshell, as per its own description, it's a troubleshooting, monitoring, and profiling framework, which comes with the Java virtual machine. So it's part of OpenJDK since version 11. It used to be part of the commercial JRocket JVM. Later on, it got open source, and now you can use it for free if you are using OpenJDK. And as I said, it's this kind of event recording engine. So you have all kinds of event types which you can record and analyze. By default, you have 150 events or even more built into JFR. There's events for memory object allocations, I/O with the network or with the file system, garbage collections, locking behaviors, class loading, all kinds of things. And with each release of Java, new and additional events are added. But then you also can add your own custom event types even. So if you would like to analyze your own application characteristics using your specific event types, that's also something you can do. And now here for JfrUnit, we are using this in the context of testing, but really this is meant for production. And people use it, or it's meant to be used in a continuous always-on mode. So really, the idea is to run your application always with Flight Recorder enabled. Maybe you have some sort of size-capped recording, which allows you to keep the JFR data from the last 30 minutes or the last hour maybe. And then if something happens in production, you get some sort of regression, some requests go very slowly suddenly. You can analyze the data and you can try to understand what's going on. There's two ways how you would do it. So there's the recording file-based way. So by default, JFR will produce recording files. But then since Java 14, you also have this ability to actually stream JFR events in a real-time fashion. So there's an event streaming API. And this actually also is what JfrUnit is using. So it's using this event streaming API. And here on the right-hand side, we see one event which represents a garbage collection which happened, and then it has all those attributes which help you to understand more about this collection, like the duration, what cause was triggering this, and so on. So that's Flight Recorder. And now those recordings, we also need to understand and analyze them. And this is where mission control comes into the picture. So it's another project which is developed under the OpenJDK umbrella. And it allows you to control recordings, to start them, stop them, and also to visualize and analyze your recordings. There's a few more things. You can also use it for heap dump analysis and so on. But here, for our purposes today, we are going to focus on the JFR analysis aspect. So that's mission control. And now I've mentioned all those tools, and I feel we should take them into practice, and I have prepared a little demo for that. So let's switch to my IDE and see what we actually can do with all these things. So let me go here. All right, so I got a web application prepared, and it's a very basic CRUD application for managing to-dos. So it has APIs for getting to-dos, for persisting to-dos. It's using a Postgres database underneath, and it's implemented using the Quarkus stack. So Quarkus, that's a stack for implementing microservices or all kinds of apps really in a cloud-native fashion. So if you would like to run on Kubernetes, those kind of things, well, Quarkus would be a very good stack for doing that. So that's what I'm using here. And I have already implemented a few tests, and I could show you a few things like how we could go about I/O analysis and so on. But I would like to focus on a very particular aspect, and this is analyzing the SQL statements which are emitted by our application. So I have prepared this test. Let's take a look at it. So what's happening here is, let's take a look at that one here actually. So let's go here. So that's what I'm doing is I enable those events. No, sorry. Let me go back. I'm a bit confused. I should be. All right. So here, that's okay. Sorry about it. So here I'm going. Those enable events, I actually have those socket read and socket write events, but they are not too important for my purpose here. What I actually also am interested I'm interested in the actual statements which are executed. So now the thing is, there is no built-in event in the JDK or in JFR by itself, and also not in Quarkus or Hibernate, which I'm using here as the persistence layer, which would provide me that information. So somehow I need to come up with another way for producing JFR events which represent the SQL statements my application is executing. And for that, I'm using this tool which is called JMC Agent. And JMC Agent, that's a Java agent which allows me to instrument existing libraries and their bytecode to emit additional JFR events. So, and that's what I'm going to use here. It's configured via this XML file in that case. And what's happening here is you specify the event type. So I would like to produce an event type named JDBC prepared query. And you need to specify at which method invocations this event should be emitted. And here in this case, so actually I'm not instrumenting Hibernate or M itself, but I'm instrumenting the statement, the connection pool, which is used underneath. So I'm using this class here, prepared statement wrapper. Now, whenever this method execute query is invoked, I would like it to trigger a JFR event, which represents the fact that the query has been executed. And it also should have the actual SQL query as a field within the JFR event. And I do this for prepared queries, and I do it for a few other events, but you got the idea. You specify which methods should trigger an event. So that's what I'm doing. I need to run this test using this agent. So let me go back to my test. And what's happening here is now I invoke my endpoint of my to-do application in a loop. And what I would like to do is I would like to filter on the JFR events, which represent queries. So let's see how that is done. I just look for the name, prepared query. And for each of my events, well, I just count them actually. So now in this case, in this assertion, I'm saying I would like to have as many SQL statements executed as iterations which I were running this, of which I invoked this API here. So I do this, let's say 10 times. I invoke this API, and for each invocation, there should be one SQL statement executed. So let me run that test, and let's see what's happening. And actually, I prepared one, which is a good one. So this should be passing for me. And then I also prepared this one here, which, well, it's already in the name. It actually represents some sort of regression, which I built into this. So now let's see. It takes a while. So this launches Postgres via test containers. Then it inserts some to-dos, and then it invokes this get-to-do API in a loop. So let's see what's going on. This one is passing, so that's good. And now my regression test, so this one is failing, which in this case I expected it. So let's see what's going on. So it has failed. And I can take a look at its message down here. So actually, I expected it to yield 10 SQL statements, but I got 60. So 6 times as many SQL statements as I was expecting. And of course, the question is, why is this happening? I can see the statements also here, so they are logged, but I would like to know where they are coming from. And now the good thing is that JfrUnit also creates a JFR recording file just for this test. So this has been persisted. Now I can go over to mission control and take a look at this recording file and see where those additional SQL statements are coming from. So let me do that. Going to mission control, and I open this recording. So this just got created. And now there's lots of bespoke views in JMC, which I could use to analyze my class loading, memory characteristics, and so on. In this case now, I'm just using the raw event browser, which gives me a view over all the JFR events in this recording. And now I'm just interested in those prepared query events. So those are the ones which my application emitted. And now I see here where and when they were executed, and also what the actual statement was. And let me make it again a bit bigger. So I see, okay, there's those additional selects which I didn't quite expect. So I would like to select a single to-do. This should cause a single select statement. But here I got all those additional to-do detail selects. So this is interesting. And I'm wondering where they are coming from. And I also can take a look into the stack trace. So here, down here, I see the stack trace where those events were produced. And now if I know this application a little bit, I should be able to find my actual to-do resource class. So there you go. And this is the method which actually was triggering it. To-do resource, get with SQL regression. So usually you wouldn't have it in the name already, but now I can take a look into this method and see what's going on there. So I used JMC to understand where those events were produced and what their cause is. So let's take a look at this method here to understand what it is doing. So I'm back in my IDE. I open up this to-do resource class. And now let's take a look there. This was the method I had, get with SQL regression. Now this is what's happening. So I do this one select here, find by ID. And now I have also details which are associated to it to do. And apparently somebody on my team changed this code. Now for each to-do's detail, they did another select which selects the particular detail and its title information. So I have this classic situation of an n+1 select, which of course isn't ideal. So now I have understood what is the actual problem here. I have this n+1 select situation, and what I would do now, of course, is I would change the code to make it to convert it into some sort of fetch join, so that I'm back again to a single select per to do. And all in all, this is how JfrUnit and Mission Control allowed me to understand about that issue and find out via unit test, right? So maybe this would have run on my IDE, it would have run on the CI server, and I would have found out about this issue about before this code would have been shipped to production. So that's the idea. And I could do it similarly for the raw database I/O. So this is where those socket read and socket write events would come into the picture, because I could assert on the bytes which I had I/O with to the database. I could think about object allocations and many other of those proxy metrics. All right, so let me go back to the slides and do a quick wrap up. So I hope I could make the case that with JfrUnit we can implement very robust performance regression tests. So by relying on those proxy metrics, we didn't depend on the specifics of the environment. So it doesn't matter, is this test executed on your laptop? Is it executed on a production-like environment? Is there much concurrent load, really? Those proxy metrics, they are very stable. So I got robust tests, which is very nice. And I also got a very fast feedback. So I learned about those potential regressions very early on. So way before I ship this into production or into some integration testing environment, I can find out about those things very, very early, maybe even during development. So that's a good thing. What's very important to keep in mind is those metrics, they need a very solid understanding. So in particular, if such an assertion fails, it may be a problem or it may not be a problem. So if you think about object allocations again, so maybe our application is suddenly allocating more objects than it used to do. Well, this could be a problem because, well, it allocates objects for no good reason, and then we should fix it. Or it could also be, well, maybe the use case has been expanded, the application is just doing more, and those actual those allocations, they are justified. So it's something which, the price is worth paying. So we need to understand about those metrics, and we need to understand why assertions may fail and whether it's actually a problem or not. So this is telling about indicators and potential regressions. You have to really understand what's going on. And of course, also the other thing is you cannot identify all kinds of performance issues. So let's say you have something like locking issues, which only show up under a high load. Well, you wouldn't find out about those kinds of issues. And lastly, there might also be things which are out of the control of your application itself. So something like maybe an index in a database, which used to be used before, now suddenly isn't used anymore. Well, you wouldn't find out about this using this testing approach. To wrap it up, I hope I could make the case that JfrUnit can be a very valuable tool in your toolbox. It should amend other means of performance testing, but in combination with those, I would say it's very efficient. It allows you to gain very interesting insights early on. Using JMC agent, you can instrument existing libraries and their bytecode to emit additional events. And on a meta level, I would make the point, definitely move on beyond Java 8 or 1.8 if you are still on it. So JfrUnit by itself would require newer versions, but also there's many things, many performance improvements in terms of garbage collection and so on. So definitely move on to newer Java versions. As an outlook, one thing I would like to do in JfrUnit is keeping track of historical trends. So let's say your metrics, they decrease over time slowly, maybe bit by bit in the course of half a year. And maybe each little step didn't matter too much, but taking the data from now and comparing it to 6 months ago, maybe that's a substantial regression. So we would like to analyze those longer historical trends. That's something we would like to explore down the road. Lastly, a few resources. It's all open source on GitHub. So here's the repo, or you will also find those examples there. There's a blog post which introduces it on my blog. And there's a few other resources which you can see here, which help you to understand about JfrUnit, JFR, JMC agent, and a few other tools. That's all I had for you today. I would be very happy to answer your questions. You can hit me up via email. You can find me on Twitter. And I will also be in the speakers lounge later today to answer all your questions. Thank you so much.